Hi guys, welcome to Unit 6, Lesson 7, the Pythagorean Theorem in 3 dimensions. Alright, so 3D figures. We see triangles in 3D figures all the time. The most common places are cones, pyramids, and prisms, okay? And really the triangles can come from just cutting it into pieces, right? And looking at like the height versus the diameter or the base, whatever we're looking at, okay? So that's what we're referring to. And so hopefully my pictures make sense and we'll go from there, okay? So for my first example, I've got this cone. So if you can imagine it being 3D, kind of like a birthday hat, okay? That's what this reminds me of. And I'm told that the diameter, which is the length all the way across the base of a cone is a circle. So the diameter is 10, okay? But what I'm looking for, let's see, and I know the slant height. The slant height is 13. And if I know the diameter, that also means I know the radius, which is what I need for this triangle. Okay, so looking at, let's see, first let's start with that. I'm getting ahead of myself. So if the diameter is 10, the radius is half of that. So that means that the radius is 5. So that length in my triangle, so it's like a drawing from the side of the cone into the very center of the cone. And then what we're looking for is this length right here, from the center of the bottom of the cone up to the opposite vertice. That's the height of it, okay? Which is also one of my legs in my triangle. All right, so when I'm building my formula, I've got a squared plus b squared equals c squared. Well, I could consider my height as a. That's what I'm looking for. The variable doesn't matter. It's just that's the number. Those are the letters that we're used to hearing. I could have put h squared in there, and that would have been fine too. Okay, so that's what I'm looking for. B squared. Well, that's my radius. So that's 5 squared. And then my hypotenuse, that's this length here, my 13. So I've got 13 squared on the other side. Okay, and by solving for A, I'm going to find the height of the cone. All right, so let's see. I don't have 13 times 13 memorized. That gives me 169. Okay, and then 5 squared is 25 plus A squared. Well, let's start getting A by itself. So I'm going to subtract 25 from both sides. They'll cancel over here. I'm left with a squared is equal to 144. Ooh, I like that. I like that. To get a by itself, I need to do one more step. I need to get rid of that square, and in order to do that, I need to square root both sides of the equation. They're going to cancel over on the right because they're opposite of each other. So I just have a on my left, excuse me. And then the square root of 144, I like that one because it's a perfect square. Because, and maybe you already know it, and if you do, awesome, right? But let's see, square root of 144 is 12, right? Because 12 times 12 is 144. So the height of the cone, what that tells me, and I know what my numbers are referring to, they're all centimeters. So the height would be 12 centimeters. Okay? So it's just finding the right values and making sure that we're putting them in the correct spot within the formula. But the formula hasn't changed at all in several units, so that's kind of nice. With this next one, we're given a whole bunch of different values for this rectangular prism, okay? And what we are looking for, we're given, we're finding D. That's this right here. But we know the value of X, and we know the value of the height, and both of those are the values that we need in order to find D, because if you notice, that gives me a right triangle, because this is like flat on the ground and this is going straight up vertically. Okay, so that gives me a right triangle. So H, I can say that that's equal to A. X, I'm going to make equal to B within my formula, right? A squared plus B squared equals C squared. And D, that's going to be, that's equal to C within my formula. Well, I'm told that H is equal to 18. I'm told that X is equal to 36.1. So within my formula, A squared plus B squared equals C squared. I'm going to have 18 squared plus 36.1 squared equals C squared, or I could have put D squared in there also, right? So let me get my calculator back up. Well, 18 squared, that's the same thing as 18 times 18. That gives me 324. Okay, I'll clear that out. Then I've got 36.1 times 36.1, or I could have used my square button. So 1,303.21, and that's still equal to C squared. Well, I'm going to add the 324 to it. Gives me 1,627.21 equals C squared. To get C by itself, I'm going to square root both sides. Those will cancel over on my right, and I'm left with C. So then, oh good, it did. I was wondering if it would do it if I hit square root after the number, but it worked for me. All right, and that gives me 40.3386911. Right, but we don't need all of those values. I'm going to say that this is either 40.34, or we could just say 40.3, depending on what it's asking you to round to, okay? And I didn't write that down, unfortunately. And they were all in inches, so my answer should be in inches as well, okay? So there we go. It's just finding the triangle and figuring out which values that they gave me actually make sense, okay? All right, this one looks like a doozy, but it's really not that bad, okay? So this is number 3 on your quick check. It looks long and scary. I wrote the whole thing down, and then this is the picture that they gave us as well. So Chemtech, I'm guessing that's like some kind of company. Chemtech makes paper cones used to filter liquids in lab experiments. To make the paper cones, the company starts with the net of the shape. So first off, we need to know what a net is. A net is like the flat version of a three-dimensional shape. Okay, so if you were to take like, this is if you were to take a cone, like a three-dimensional cone, and you were to flatten it out, this is what it would look like. Okay, or if I were to cut it out, then I could fold it back together and make it into a three-dimensional cone. Okay, where the slant height is needed. The company wants the height to be 6 centimeters. If they make the diameter 30 centimeters, what will the slant height be? So the slant height, and if you remember from the previous question, number 1, that we went over, the slant height was my hypotenuse, okay? The height is one of the legs, and the radius of that circle at the bottom is the other leg, okay? So we are given the diameter, let's see, so we're given the height. The height is 6 centimeters, and the diameter is 30 centimeters. But I don't need the diameter. I don't need to go all the way across, right? I only need to go halfway across, because that's where we measure the height from, is the center of the cone, right? So that would be right there, which also gives me my radius. So if the diameter is equal to 30 centimeters, then my radius is equal to half that, which is 15. Okay? So this is also equal to one of my legs, so I'm just going to label this as A. And then the height is 6 centimeters. I'm going to label that as B, right? Those are my two legs. We're looking for the slant height, right? Slant height is going to be equal to C, okay? And that's enough information for me to fill in the formula, right, as a squared plus b squared equals c squared. Well, I know that my a is 15, my b is 6. I'm still looking for my slant height, all right? So let's see, 15 times 15 is 225. 6 squared, or 6 times 6, is equal to 36. Add those together, let's see, we get 261. In order to get c by itself, I have to square root both sides, just like we've been doing. They'll cancel on the right, and I'm just left with c. And then on my calculator, sorry, had to clear it, got 261, and we're looking for the square root of that. Well, that gives us 16.1549 on forever and ever and ever. Okay, so 16.15, I'm just going to say 0.16, or we could also say 16.2, and they were centimeters, so this should be in centimeters as well. So again, depending on what it asks for, whether it's rounded to the nearest tenth or to the nearest hundredth, that could determine which answer you pick. Okay, so I hope this helps, and reach out if you need extra support.